Hi friends, I'm Mohammad Usman. I'm going to take about real-time CPU scheduling. Real-time CPU scheduling in OS optimizing page operations. These are the contents. First one is introduction to CPU scheduling. Real. The second one is real-time operating system (RTOS), and the third one is real-time CPU scheduling techniques. There are various techniques available in that. And the fourth one is real-time scheduling for page operations. And the fifth one is future trends in real-time CPU scheduling. And our first introduction to CPU scheduling. Now we are going to see about the introduction of the CPU scheduling. Importance of scheduling: system efficiency. Effective CPU scheduling enhances system performance by optimizing CPU usage and reducing wait times, leading to quicker response times for user applications. This is system efficiency. And resource management. Scheduling allows for optimal allocation of CPU resources, preventing bottlenecks and ensuring that multiple processes can run efficiently without overwhelming system capabilities. General scheduling algorithm. First come, first serve. FCFS is the simplest scheduling algorithm where processes are executed in the order they arrive, but it can lead to issues like the convoy effect, delaying shorter process. This is first come, first serve. Let me see it in detail. First come, first serve. First come, first come, first serve is one of the simplest CPU scheduling algorithms where the process that arrives first is executed first. It operates like a queue, first in, first out, meaning the first process in the queue gets the CPU first and continues until completion. There are various characteristics of first come, first serve. Non-preemptive. Once a process starts execution, it runs until completion. Fair scheduling. Every process gets a turn it on in the order it arrives. Simpler implementation uses a FIFO, first in first out queue, to manage processes. Can cause the convoy effect. A long process can delay shorter ones. Let's dive into shortest job next. Shortest job next. Prioritize processes with the shortest execution time, minimizing average wait time, but can suffer from starvation for longer process if not managed properly. SJF, that is shortest job first, is a CPU scheduling algorithm where the process with the shortest best time is executed first. It is also known as shortest job next, SJN. There are types of shortest job first scheduling: non-preemptive SJF, preemptive SJF. Once a process starts execution, it runs until completion. This is non-preemptive. If a new process arrives with the shortest bus time than the currently running process, it preempts the current process and executes the new one first. This is preemptive SJF. Now let's see the third one. Real-time operating system, RTOS. Characteristics of RTOS. First characteristic, deterministic behavior. Second one, minimal jitter. Third one, rapid response. First we see about deterministic behavior. Deterministic behavior ensures that the system can predictably meet the timing constraints set for task execution, critical in environments requiring reliable responses. Minimal jitter. Minimal jitter refers to the reduced variability in task response times, which is essential for maintaining consistent performance in time-sensitive applications like automation and control systems. Rapid response. Rapid response indicates the ability of the operating system to quickly execute high priority tasks, crucial in scenarios where delays can lead to system failure or unsafe conditions. Types of RTOS: hard real-time RTOS, that is HRTS, and soft real-time RTOS. First, hard real-time systems. Hard real-time systems guarantee that critical tasks are completed within strict deadlines, ensuring that failure to meet these deadlines leads to catastrophic outcomes in applications like aerospace or medical devices. Tasks must be completed within strict deadlines, otherwise system failure occurs. Missing a deadline can lead to catastrophic consequences. Example applications for hard real-time systems: medical devices, aerospace systems, industrial automations. Example of hard RTOS: VxWorks, QNX, RT Linux. Now soft real-time systems. Soft real-time system allows for some level of deadline miss without severe consequences, making them suitable for applications like multimedia streaming, where occasional delays are tolerable. The definition of soft real-time OS: meeting deadline is important, but occasional delays are tolerable. The system degrades gracefully if deadlines are missed. Example applications: multimedia streaming, example video conferencing, online gaming, telecommunication, automotive systems. Example of soft RTOS: Windows CE, Linux with RT patches, embedded Linux. And the third one is from real-time OS. The definition of from real-time OS is: deadlines are important, but missing them does not cause total failure. The task usefulness drops significantly if delayed, but the system remains functional. Now, real-time CPU scheduling techniques. We are going to see about the techniques. Rate monotonic scheduling. Principle of operation. Rate monotonic scheduling assigns priorities based on the periodicity of task. Shorter period tasks receive higher priority, ensuring prediction task execution. Use cases. Commonly used in embedded system and real-time applications where tasks have fixed periodic behavior, such as automotive and robotic systems. Limitations: it cannot guarantee the scheduling of a set of tasks with arbitrary deadlines, leading to potential missed deadliness in high load scenarios. Earliest deadline first EDF. Algorithm principles of EDF. EDF dynamically prioritizes tasks based on their imminent deadlines, allowing the CPU to schedule the task that will complete first among all ready tasks. Application scenarios: useful in scenarios where tasks have varying execution times and deadlines, such as multimedia applications, network communications, and adaptive control systems. Least slack time first LST. Algorithm mechanism of LST. LST schedules tasks based on their slack time, calculated as the amount of time remaining until the deadline minus the time required to execute the task. Practical application: applicable in high performance real time systems where tasks need to adaptively respond to changing operational conditions, like systems. Avionics systems. Pros and cons of LST: provides flexibility and better resource utilization, but may incur high computational overhead due to frequent revolutions of task priorities. Now, real-time scheduling for page operations. Memory management in RTOS. Paging mechanics. Detailed description about this title, about 20-30 words. Paging mechanics involve breaking down the memory into fixed size pages, allowing efficient memory allocation and minimizing fragmentation, critical for real-time operations. Page replacement strategies. Detailed description about this title, about 20-30 words. Page replacement strategy determine which pages to swap out when memory is full, influencing system performance, latency, and satisfying real-time constraints in critical applications. Real-time constraints. Detailed description about this title, about 20-30 words. Real-time constraints specify the timing requirements essential for system responsiveness, ensuring tasks meet deadliness without compromising overall system performance. Case studies: industrial automation, embedded systems, real-time databases. These are the case studies of real-time OS